presentation. I'll only show you examples and.
Sorry, man. I couldn't Are you a hacker?
Huh?
I'm a phone hacker.
So different people may have different.
Just admins, use Python.
Jason, I know this is an important thing, but I really couldn't walk on myself.
If you can mute your microphone, that would be great. Thank you. So different people have different goals in terms of programming. In a practical sense, you can use, in terms of using programming to transform your ideas or your creativity into an actual software product. And some people do this just for automation, so you don't want to do the same thing again and again. So you can write up a script of programs to do it for you. And so you can have your mind or your brain to do something else more interesting. And in terms of data science or computational sciences or data processing, we can use programming to help us to do data processing, visualization, or even discovery and see other insights from the data. And in a way, programming is some kind of understanding. And in my personal experiences, sometimes through the process of programming or try to build a program, you can often find insights into the problem. And that may help you in the future to solve the problem more effectively. And so to do all of this, we will need at least one programming language. And for today, the choice of our language is Python. And I will give you my reasons why Python is a good choice. And I will show you a few examples why we are doing this way. And for me personally, I'm a Python user for years, and I use Python on a daily basis to do my work. And so I really depend on Python. So I wouldn't recommend it to you if I don't use it every day. And so as a tool to do data processing or computational work, Python is a really good choice. And today I'm going to show you some of the language features and then show you a few very simplified examples, because some of you may not be familiar with Python at this point. So the examples are really simplified, and hopefully I'm trying to highlight the key point in the example, not the language complexity per se. And so hopefully all of this exercise will motivate you to want to study more about this language. So before we jump into Python, I would like to say a few words about the language, the so-called language dimensions. So there are different aspects of choosing a language. So some people pick it because you maybe already know it. But here I want to show you that the language has different aspects. So some languages are called interpreted languages and versus the compiled languages. And the interpreted language is easier to write, like Python. And the compiled languages like the C or C++, they are good for high performance, but they are harder to write and they have to be compiled. And also some languages are for specific purposes and others are for general purposes. Python is a general purpose language, and you can find specific purpose languages in other areas. But here we are kind of going with the general purpose Python because it covers a variety of areas that you can do with a single language. And also some people put language in terms of high level or low level. Python is a high level language, and a high level language usually take care of some of the details for you. So the program is easy to write and easy to understand, easy to read. Low level languages allow you to control, for example, the hardware. And so, for example, language like C or assembly, you can get very close to the hardware, but then you have to take care of a lot of details. But Python is a high-level language, so a lot of things are taken care for you. So you can kind of focus on the problem itself. And Python can be used in two ways. One is the interactive way. So you can sit in front of a Python command prompt, and you can type, and then the system will respond interactively. So this is a good way to explore data, or when you try out the new ideas in Python, and to experiment with your data. So this is a kind of very easy and convenient way. And people actually do this in serious work. So interactive use of Python is a good way to explore data and do processing. And the other way is called a batch use. So you don't want to do everything interactively. For example, if you already have a workflow and you want to process your data in a kind of repetitive fashion, so you would write your Python into, you will save your Python command or a program into a file or a set of files, and you will run them in a kind of a batch mode or production runs. And so we will talk about both of these cases briefly. And a little bit of history. Python has been around for a while, and it was first released in 1991, and over the years it was updated to 2.0 series and then 3.0 series. And there is a Python Software Foundation, and this is a non-profit foundation. And the Python, the software itself is open source, free software, so you can download on any machines you like and use it freely. And currently, in a real, like a mainstream use of Python, both 2.7 and 3.x are currently in use. Unfortunately, these two are slightly incompatible with each other, but that's just the fact, because the 2.x series has been around for a long time. So a lot of code base has been established. So it's not, the momentum is so big that it's not so easy to switch to 3.x, although 3.x will be the future. So we will kind of briefly mention the differences and provide more details in our class next week. So before talking about the language, we have to, we can take a look at the language rankings. So, and you can see different rankings from different sources. And here I give you two examples, and just to show you that Python is one of the mainstream languages, and that's probably one of the reasons you are here today. And when looking at the language rankings, I wouldn't look into the numbers too seriously, because the languages are for different purposes. But here, at least we can see that Python is among other kind of mainstream languages, and it can be used for building websites, and you can do it for so-called enterprise use, or to build a program to do data processing and all that. And this is just another ranking, and like I said, the ranking number doesn't really mean much when you consider the specific purpose of the language. But you can see that again, Python is among the top 10 mainstream languages. So it is a good investment to learn Python. And so we talk about Python as an object-oriented programming language. But you can look closely. So what exactly is an object? And so when people say object-oriented programming, or OOP, what is an object exactly? So there are rigorous definition in computer science, but in practice, or in a simple sense, an object, something that contains data and a bunch of associated member functions. Member functions are, if you have learned the functions from another language, the function is just functions, but these are special functions associated with the object. So object is kind of an umbrella, kind of a container containing all of this, or only one of this. For example, in Python, suppose we have a string called hello world. So single quotes a string object in Python, and equal sign we assign a string object to a variable called a. And I will have more of this kind of example in later slides. So you will see this 3 greater than signs. So these are just the prompt from the Python interactive command. So you can ignore this greater than sign. So we assign hello world string to a. So like I said, a is an object. So everything is an object in Python. So again, the object will contain data and member functions. So in this case, the data is this hello world, the words hello world. These are the data. But then automatically, because it's a predefined string is a predefined object in Python, automatically it comes with a bunch of member functions. For example, the a variable has a member function called upper. So this particular upper function will apply to the data of the a, which is hello world in lowercase, and it will return the uppercase hello world. Right? So this is an example of a member function can apply operation on an object, on the data of the object. And another member function of interest is that there's something called center, and you can give the total length of the output string, and you can say this is the appended character of the to perform this center function. So the result of this is that it will give you original hello world padded before and after with the dash character. So this is another member function applied to the original data. And there's another member function called split. So split will take your original string and find the white space in the strings, and then split the words according to the white spaces into and return a list of the words. So these simple things can become very useful when you actually process your real data, as we will see in later slides. And so when you use Python interactively, you can actually inspect the object. For example, there is a command called dir in Python interactive command prompt. So A was our hello world string object. So if you run the dir command on A, it will show you all of the member functions associated with the object. So in this case, you will see that a pretty large output. So these are all of the member functions associated with the string object. And you see that the words in red here are the member function we just used. We apply the center, we apply the split, and we apply the upper operation on the data hello world. But then you can see that there are many other member functions you can potentially use. So you see that Python, like I mentioned, as a high-level language, it comes with a lot of these kind of things by default. So you don't have to use all of them, but then they come in handy when you have to perform certain operations. And unlike C or C++, in Python, these things are available for you to use right away. So you don't have to write your own parsing routines. For example, if you do this in C, you will have to write a bunch of functions before you start to do anything. But Python is kind of come with everything you potentially need. And when we talk about the data, then data in computer, in many programming languages, you will have different data are categorized in different types, because textual or string data are different from numeric data. At least in one sense, you can perform algebraic operations on numeric data, but you cannot really do so for the textual data. So in Python, you can inspect an object, the type of an object. For example, I look at there's a command called type in Python, and you can apply type to any object. For example, I have an object 3, the number 3, and this is by default, this is integer type. Or you can inspect some kind of number with decimal points. It will show you this is a float type, and the hello string is a type string, and there's also a true and false type. So this is useful when you do logical operations, or when you check the condition of something. So this is a bool type. So it's a true or false. So all of this are the kind of the built-in data types, and you can build your own data type on top of this. So you can derive a very complicated data structure on the top of the base data types. And when you look at anything talking about object-oriented programming, you may come across a term called operator overloading. And that term has its own rigorous definition, but in a practical sense, this basically means that different operators can mean different things for different objects. And here's an example. Suppose I have a variable A, and the value of A is 3, and the value of variable B is 4. And what is A plus B? So naturally, this is 7, right? 3 plus 4. But this is because the addition operator associated with this integer data type is to perform algebraic addition, right? So 3 plus 4, you get 7. On the other hand, if you have two lists, so list is a Python type that we will talk about more later. So suppose I have two lists. The first list has 2 numbers, the second list has 2 numbers. And if I do x plus y, in this case, the addition operator is now associated with the list data type. Now, this operator doesn't do the algebraic addition. It actually combine the list together. So when you do x plus y, you actually get a longer list. So this is a kind of a union of the two lists. So they just patch the list all together, and you can do it. You can apply this to a more complicated list. So this is just to show you that different operators can mean different things for different object types. And you can define, once you learn how to write Python code, you can actually define your own classes, and you can define your own operator overloading. So potentially you can develop very complicated operations by overloading some of these operators. And the goal is that the code can look simpler or be simplified if you do this. If you predefine operator overloading, then some of the complex code will look easy for the other users or for other readers to read. And again, we kind of around this idea of data. So data is associated with types, and you can associate with operator to data. But in practice, you will have to put your data somewhere. So in Python, the language comes with a few very powerful built-in the so-called data containers. So these are basically the kind of a container, as the name indicates. It will hold one or multiple data entries. And these are some of the default data containers. And you can build, again, and Python is a very flexible language. You can build your own containers or define your own containers. And let's look at some of the examples of what this container can do. So one of the probably most useful data container is called list. And the list is nothing but the indexed collection of arbitrary objects. So what does this mean? So for example, a list A can be a collection of a lot of items. And one thing you notice that you see that all of these items do not necessarily have the same data types, right? So the first one is an integer. The second one is a floating point. The third one is a string. And the fourth one is actually a function. So you can define, we will talk about function later, but you will see that a list can contain, in addition to data, but it can also contain a function. Although in practice, you don't really want to arbitrarily just put a collection of random objects into a list. But this is just to show you that potentially you can include function in a list. And there are scenarios that you want to do this to simplify it or to make the program run effectively. So Python, you can actually mix different data types in a list. And like I mentioned earlier, the list is actually indexed. So to retrieve or to access the data entries in the list, you access them by the index. And this is a zero-based indexing, meaning the first element is index 0, the second one is index 1, and the third one is index 2. So when you say A square bracket 0, so you are accessing the first element of the list A. So this will return the value 42. So that's the first element. And so if you say A bracket A2, so A2 is actually the third element because this is zero-based indexing. So it will return the string hello. When you try to access the A3 is the fourth element. So like I said, this is a function. And although this value is not very useful, this is a memory address of the function, but it indicates that you are retrieving the function. So in practice, you can actually call this function by accessing this index number. And we will talk about this later. And you can, so again, a list is an object, right? So our list A is an object. And then again, we mentioned earlier, the object has a bunch of built-in member functions. So that's also applied to the list. So for example, I have a list of numbers, and then I can perform operation on this number using the member functions. For example, there is a member function called append. So append actually append one additional element to the list. So this was our original list, and we will append 5.3 to the list. So without doing much, and the code actually is kind of readable because you see the word append something. So even by a non-Python person, when you see this, you can kind of guess what it does. It appends something, and you will get the longer list. You can also insert elements into your list at the arbitrary locations. For example, I insert -99 into my original list and at the location 2. So this is zero-based indexing. So 2 means the third element. So this is the inserted element. You can also take out elements from a list. So this is called pop. So you can pop out elements from the list. So the list becomes shorter after you pop the element. And so these are kind of simple functions, but they become extremely useful when you need to manipulate your data. And there are times that you have to transform the entire list to something else. For example, in this simple case, I have a list of numbers, and the numbers could be in your real data. This number can be from your other data sources. And so for these numbers, I want to perform certain operations to the entire list. And the way to do this is that I write a for loop. And a loop is a construct that lets you go through every item of something. And so in this case, we say for x in A. So A is our original complete list. So for every element in A, we do something. So this is what this means. So in this case, for every element in A, we will print 10 times that element, right? So A is this list. So 10 times every element. So you will get an output of 10 times of every element of A. So this is one way to do it. And Python has a syntax called list comprehension. So this is a kind of a compact syntax, and actually is runs more efficiently in Python. Is that there's a syntax. So our goal is to construct a new list, and where each element is 10 times of the original element in A. Right? So we can write this and say new list for every element in B, in the new list B, the value is 10 times S. So S is any element in A, we multiply by 10 and put into the new list B. So B will be this, like 10 times A. So this is a powerful construct. And for this kind of silly, simple case, it doesn't really make a difference. But when your list is large, and under some scenarios, this syntax actually runs much faster than writing a loop. And we will kind of dive into these details in our class next week. And a kind of an interesting exercise is to, now we know how to deal with list, and we know how to deal with the for loop. So to iterate through every element in the list. Now, an interesting exercise is that, so suppose I have all of the words I loaded from an English dictionary, right? So X is the list of the words, and and now this is a long list, but it's a Python list. Now, if I ask you to find all of the 3-letter symmetric words, right? So for example, like eyes. So if you read eyes from the forwards, so EYE, and this word is symmetric in the sense that if you read the word backwards, it also spells EYE. So suppose I said, okay, find all of the 3-letter words that look like this. Now you can, now you know Python, you can write this in a few lines, right? So for every word in my dictionary list, so for every word I call W in the dictionary, capital X, if the length is 3, because I'm looking for 3-letter words, and if the first, because a list is a zero-based indexing, so W0 will be the first letter of the list. And -1, this is a special indexing in Python. This means the last element in the list. So if the first and the last are the same, I will print out the word, right? So this will give you all the words that look like I. So for this output, you will see that ADA is such a word. AHA is also such a word, right? ANA is also a word. So you see that you get all these 3 words that are 3-letter words that are symmetric. And here I give you the output of some other, under some other conditions, right? So there are 4-letter words that are symmetric, or there are 5-letter words that are symmetric. So this is, so you can actually see a lot of words normally you don't notice, but then you see that they are actually symmetric. And these are, they are also output from other combinations. And this will be one of our exercise problems in our class. So with a simple, like a few lines of code, so you can kind of generate kind of interesting output. And another different type of container, so that was list, and list is already very useful. But in other scenarios, you may need a different kind of container, and there you need something called a key value pairs, and this is a kind of a good way to look up something. For example, and this is called a dictionary in Python, and maybe called a lookup table in other contexts, but in Python, this is a dictionary, but essentially a kind of a key value pairs. And what does that mean? So you can create a key pair values, a set of key pairs, key value pairs, sorry. So for example, John, and say your midterm score is 60. So the key will be John, the string John, and there's a value associated with the key. And they are associated with each other by this column, right? So John is 60, and maybe another key, Marie, is 75, right? And you can build a large dictionary this way, but basically it's a key column, the value. Now B is this dictionary, and if you check the type of B, it's a dictionary type in Python. Now, suppose I want to retrieve the value of John, right? So I would refer to this guy by the key John. So when I say John, B bracket John, it will return the value associated with John. So this is different from list. In list, we just access the element by the indices, the 0, 1, 2, 3, the indices. In dictionary, you access the element by the key. right? Because sometimes the integer indexing is not the most convenient way to do the indexing. In some scenarios, this is a better way to index your data. So this is the key value. So this is you can build a very large dictionary to hold your data. And again, a dictionary is also a Python object, and the object again has its own member functions. And some of the useful member functions are, for dictionary, it's not so obvious how you traverse the entire dictionary. In a list, you can go through the indices, 1, 2, 0, 1, 2, 3, 4. You can traverse the entire list. But in dictionary, there seems to be no easy way to traverse the dictionary. But that's why you need the member function keys or values or items. This kind of member function pull out the entire, all of the keys or all of the values of the dictionary. The items pull out key and values simultaneously. So if you write a loop and go through a.items means retrieve all of the items in dictionary A. And so for all of these items, I print out each item. So then you will see Mary value is 5, and then John value 2. So this is just a way to traverse all of the items in the dictionary. And sometimes you need to do that because you may be looking for something. So you have to go through the dictionary and to find the item you want. And if you know the key, then you can access that entry by the key in the dictionary. And the dictionary can be more complicated than just a single value. For example, the value part can be another Python object. It doesn't have to be an integer or a single number. In our previous case, our keys is a single number, right? But it doesn't has to be. So in this case, my list A, the key is John, and the value is actually a list, right? So this is, and you can put arbitrary Python object here. And so you access the value associated with Marie that will give you a list, right? This is the list associated with the key Marie. Now, suppose you want to access the first element from this list. So you can do it in a chain. So A Marie will retrieve that list associated with Marie. And the second index, 0, will retrieve the zero's entry in that list. So 0, because this is 0 indexing, so we know 0 is the first entry of that list. So it will give you 75. Right? So you can do it in the same way to retrieve anything in your dictionary. So you will do it in multiple steps. First, you retrieve the entry, entire entry, and then you will access the element. Suppose it's a list, you access the particular element in that value. And you can also easily insert new entries into the dictionary. And you do that just by inserting a new key. For example, your original list, in your original dictionary, you have John and Marie, right? Now, suppose you insert something called Jim, a new key, Jim, and you assign a list to Jim. Now, if you look at your dictionary, you will see that Jim is actually added to the list, right? So you can easily insert. You don't have to do anything special. You just keep inserting new keys, and your dictionary will be expanded. And what happens if you do this? If you access Marie, and we know Marie has only 2 entries, right? Suppose you are trying to access index 3. And when you do this, the program will crash, and you will see this error message on the screen. And if you see this, do not panic. This is just a way that Python tells you that something is wrong. Your computer is still fine. It's just the program stopped. Show you a traceback and show you some of the kind of technical details. But the important thing here is to identify this line. This is an index error, right? And it is an index error because in this simple example, you kind of see why. Marie has only 2 entries. I'm trying to access something that doesn't exist in Marie's list. And so this is index out of range, right? And so this is the error message. And this thing, the thing in red, index error, this is called exception in Python. And this brings up our next topic. It's called exception. So exception basically means some kind of errors, some kind of problems. And it's called exception in Python for computer science reasons. And so a program, in general, a program can run into problems. And if you are writing a program for example, you are launching a rocket to the Mars, and your program run in, and some of the mistakes you can predict and you can prevent in your program, but there are times that the problems are hard to predict. So you would want to, you don't want your program to crash. You want your program to respond with something even when unexpected problem occurs. And so exception is for this purpose. So you can, the Python exception is quite a powerful construct. You can, its syntax is called try something. So try means you are trying to perform some operations. If the operation succeed, then the program will go on. If the operation failed, Python will try to capture the status of the exception or the problems. And you can tell Python what to do after Python capture the problems. So you can write it, so you can write your program using a try except construct so that you can capture anything that you would not predict, but then you can say, okay, whatever happens, do this. Then whatever happens, Python will kind of give the control of the program into the exception handling, and then the program will not crash. The program will go on according to whatever you tell the program to do. So this is quite powerful, and you can construct, you can kind of check different conditions and exceptions in a more rigorous way. But the main idea is that there's a way to prevent your program from crashing by doing this exception. And surprisingly, the exception seems to be kind of underutilized for some of the programmers I have seen. So it's a very good, powerful way to make your program robust. And now we come to the topic of functions. So in any programming languages, usually there's something called function or subroutine or routine in different languages. So from an engineering point of view, I like to see function as an kind of like a block, in terms of a block diagram, it's an input-output block, and a function is the block itself. So you will pass some data into the function, and the function will perform some operation, and then it will generate some output. And to write a function in Python is nothing but you do a definition. def is a keyword to define a function. You define your function, and then you define what are the input data for the function, and then you write your own function, and then you return the output. And when you call the function, you call your function, you pass in maybe possibly different data, and the function output will be captured on the left-hand side of the equal sign. And one thing I want to highlight is that unlike some other languages, in Python, a function can actually return multiple objects. So this is not the case for some other languages. So, and this is actually a very nice feature. And we will talk more about this in the class. And so to talk about functions, I like to kind of say a few words. Function is easy to write, but then usually the hard part is how to divide your problems. And sometimes this has something to do with the input. How do you define the input output to a function? Because in a larger program, you have to somehow divide your problem or problem into different pieces, and each small piece will be implemented as a function. And usually there is more than one way to divide your problems. And if you divide it in a good way, then your program will be easy to implement, and the logic is clear, and your Python program is easy to maintain. But if you do it in a if you don't do it properly, then you may end up with some kind of what people call spaghetti code, and the code will be hard to read, hard to maintain, and it'll be a mess. And so, knowing the syntax is one thing, but more importantly, I think that you also need to learn how to divide and how to partition a program into. This is more of a software engineering topic, but it's a good habit to have, to always keep the partition of the problem simple and clear, and know exactly what data to pass into a function and out. And also, if you design your input-output correctly, your program will be more robust, even if you make changes to it. As a simple example, suppose I have a function, and the function will capture the name, the ID, and the address of a person. Right? So you write a function, everything is working, that's fine. Now, at some point, you realize, okay, I need to add additional information to this person, right? And I need to capture the phone number. One way to do this is to add another argument to the function. And this will work if you are the only one and there's no other places calling this function. If you are working in a larger program, or if you collaborate with another programmers, and when you make this change, other part of the code calling this function may fail, right? Because now your interface is different, and depending on what happens here, the code may crash or become kind of buggy or generate other problems. So a way to fix this is that when you think about your input-output, you can use some kind of smart container to capture the input. For example, in Python's case, I'm using a dictionary to pass in my data, right? So I have my name, my ID, my address as a dictionary. Now, at some point, I want to add additional information. I can just add the information into the dictionary, but I'm still passing the dictionary into the function. So the interface of the function does not change, although I'm kind of inserting new information, but the function doesn't change. And you can check all of these guys inside the function. And so the interface doesn't change. The other older program calling this function can still use the function as before, although potentially you can use this additional information inside the implementation of the function. So this is just a very brief example. We will have more of this in a class, but this is just one example to show that you can, even for the simple case, you want to think twice about the interface design. And for the long run, this is a good thing to have. And Python has many other features, and I will just mention a few of them. For example, date, to handle calendar date. This is a date is a common thing in many data, right? So some kind of records from a machine or some kind of transaction happening on a particular date. And surprisingly, many people still program calendar date in a very primitive way. Python has an entire very comprehensive package called datetime. So if you use the datetime package and you kind of basically abstract out calendar date in the object, datetime object. So if you can easily capture today's date as a datetime object. Right? You can just call today, it will give you today's date. So I run this earlier, so this is not today. And with the object, you can actually, for example, I want to add 5 days to this date, right? If you use the datetime object, you can just add this time delta and 5 days to the date, and that will give you a correct date. And you can say, oh, this is easy. I can do this by myself. But well, when you encounter leap years, if there are different number of days in February, and you are counting some time across February, you may have to write some logic to handle all of these things. But if you use this object, datetime, then everything is handled for you. So your code is easier to read and less bug, has less bug. And you can also capture time. And time is, I mean, it seems to be a very easy thing to do, but actually time has a lot of attributes. So you use a time object, it actually contains a lot of attributes. A local time has our current date, the hours, the minutes to the seconds, and also the week of the day, which day of the week, and all of this. And so if you use the object, all this information is carried with that object. So you can easily, for example, I want to output the date in a different format. So you can call this a date format function to output the date. So the data is there, and then so the internal data and the representation or the presentation of the format, these are two different things. So you use the object to carry the information, and then you can present the information in any way you want. And for a larger program, for example, if you write a program and you save in one file, now later on you write another program and you want to use one of the functions in your previous program. So in Python, this is called import. So you can import program from other files. And you can import the function in different ways. Suppose I have a file and I have a bunch of functions in the file. And then I have another Python file, b.py, and I have a bunch of functions. If you import A or import B, you import everything from this file, right, into your namespace. But you can also choose to import just one function. So you can say from A, I import function X. There might be other functions in the file A, but then I'm only importing one. So Python lets you decide what to import. But basically, this will give you a chance to reuse your older code. Right? You can write a code, save in a file. You can load it in a different file. And also, Python fully support creating a larger packages. So your file can be distributed across multiple files or even multiple layers of folders or file directories. Or for example, you can build a larger module and you can have your files in different directories according to different, in a larger program, you want to kind of organize your files. So maybe some part is for visualization, some part is for operation, and some kind of a common operation on this layer. So you put all of your files, and the whole thing can be viewed as a module in Python. Now you can decide to import the entire module, or you can import one of the particular function. So you can do everything you can think of in terms of the module. You just Python provide a mechanism to do that. And for data processing, a lot of times you have to kind of parse textual data. For example, given a, say, email archive, right? And suppose the task is to extract all of the addresses in the email files. And we are talking about maybe you have 10,000 emails in the archive, and you want to pull out all of the addresses, not the content. And Python has something called regular expression. Regular expression enable you to look for a particular pattern or extract certain characters from a file. And we will see in a few minutes. But basically, regular expression is a special syntax, and so that you can express this particular pattern in a very compact way. For example, in regular expression, if you put the character in front of from is just an arbitrary word. Regular expression will look for any line that starts with from, the word from. Right? We will see this in a minute. And also, you can look for example, any non-white characters. So non-white character means the space is a white character. So non-white character means it's a numeric character or ABCD, those kind of alphabetic characters. You can also narrow down to the range of the character that matches the pattern. You can say, I also I only want to match something that starts with the number 0 to 9, so one-digit number here, followed by some one or more non-white characters. For example, suppose that's the criteria, then the regular expression syntax is like this. Now it may look, if you have not done this before, this kind of looks like some kind of crazy syntax, but it's not. There is actually a certain pattern. If you sit down and spend an hour with this, you'll be very good at this. And this is extremely useful if you have to process kind of large text files, because sometimes the text file contains certain information associated with some kind of pattern, so you can extract those easily. And if you master all of the syntax, there are about 10 or 20 rules you can master. Once you know all of this, a complex search can be written in just a few lines. Here is an example. Suppose I have a large email archive files. So these are all the email exchanges. So, and the email files has this, who is sending this from, and the recipient, and the subject, and then the body of the email. And this is this is another email from a different person to a different person with a body of the email. So suppose I have a lot of this, and I want to extract all of the email addresses in this large files. And certainly you don't want to do this by hand. You can write a Python script for it. So in Python, to use the regular expression capability, we import this regular expression called RE, regular expression. Now we open a file, and now we say for every line in a file, I do some cleanup, right? Because a file may contain some kind of, because if you have used Windows or Mac or Unix, the end of the line characters are different across all these platforms. So Python has this kind of simple way you can kind of clean up those kind of messy characters for you. Now, I want to find all, and I will apply this kind of special pattern. And what this means is that give me anything that has a non-white character, followed by the @ sign, the email @ sign, followed by some non-white characters. So because this is the pattern of an email, right? An email has like some name and some address, right? So this is our rule. So something, if you see something something, print it out. And if the length is greater than 0, means it's not empty, print it out. Now you will give this output. Right? This is a large email file. This is output. And this is kind of correct, right? We do see emails and we do get our email addresses, but it's not perfect because you see you have these other characters mixed in the email. And that's not surprising because Python does what it's supposed to do, because the rule just says, give me something as something. So something as something. So this matches the pattern, right? But this is not perfect. It's kind of, it's not good, it's not perfect. So we can improve on this. So you can make the rule more strict, like this. Because suppose all my email addresses always start with alphabetic letter, right? So you can say the first letter will have to be either lowercase or uppercase alphabetical characters, followed by something, and @ something, and at the end of the email address is always alphabetic characters, right? So alphabetic character, something, @ something, end with alphabetic characters. And so this is a kind of slightly more strict rule, but this will give you kind of a perfect result. Right? You will not match those other bracket characters. So, and you can generalize this to imagine that you can apply some rule to extract the exact thing you are looking for in a large text file. And now I will just go through a few examples that you use Python to access other data sources. You can access MySQL, SQL databases, and in this case, you just import the package you need. You make a connection to the database files, then you can execute SQL commands. And so you can, in your Python script, it will connect to the database, insert data into the database, and then close the whole thing. So the data will be sitting in your database now. You can also pull data out of the MySQL database. If you know the database commands, you can know, once you make the connection, you can execute SQL commands. So of course, you have to know SQL language. You may have to take another class, but if you know the syntax, then you can use Python to perform those things that otherwise you will have to do this in an SQL console. And Python also, you can connect to other SQL databases like MySQL, Postgres, and other databases. And JSON is kind of a becoming a popular, or is a popular data exchange format. And Python has very good support for JSON. So for those of you who are not familiar with this, JSON is some kind of a data exchange format, and this is commonly used in kind of a web API. And we will show a Google Map example in a few minutes. So JSON it looks like a Python dictionary, but it's not. It's the JSON file format is defined in this official website, and I'm just going to show you that Python can load the JSON into the Python data structure in a few lines of code. So if you have JSON, you can load JSON into Python, or you can write Python data output as in JSON format very easily by loading the JSON format. And I mentioned JSON because a lot of kind of a popular web APIs or websites, they exchange data in JSON format. For example, many of you have used Google Map tools to find your path to a certain location. So here, for example, I'm looking for my direction from Las Vegas to Los Angeles. Right? I'm driving from Las Vegas to Los Angeles. If in Google Map, the software, or in the web browser, you type Las Vegas and Los Angeles, it will show you the direction and how do you go from Las Vegas to Los Angeles. You can write a Python code, and there are only 5 lines here. But although you see that this line is just a URL of the API, and this one is to specify your origin and specify your destination. Now you just pass all of this data into the Python module called request, and then you will get the response from the Google site, and I will put the response into the data. Right? The data is a Python object. Now everything's in Python, and we already know how to inspect the data object. So I could check, okay, what is data? Data is type dictionary. So you say, okay, I know Python dictionary. What are the keys in the dictionary? You see, okay, data keys. We learned this earlier, so it will print out all the keys in the dictionary. You say, oh, okay, there are only 3 keys: the routes, the status, and this GR code. And the routes is actually the information we are looking for. If you check the data type, so route itself is a list, and if you look at the first element in the route list, it is also a dictionary. So you see that this is a kind of a nested dictionary / list, right? Because this is a kind of a complicated object, but it is exactly a Python object, and we know how to navigate through all these objects. And if we do that, and then compare with our web kind of the standard web interface. So going from Las Vegas to Los Angeles, right? On the website, you will see this driving time is about 4 hours for 270 miles, right? And actually, this information is actually in the data. You can, like I said, this is a nested data structure. But if you go kind of one layer at a time, you get the routes, and this is a list. So the first element in the list, and that's a dictionary. The dictionary has a key called legs, and again, it's a list. I get the first element of the list. There is something called distance, and I print out. I retrieve the text part of the distance. That's 270 miles. So that's this guy. Right? You can also retrieve the duration, the time, the driving time, and that's 3 hours and 59 minutes. That's the 4 hours you see. Right? So all of the data is actually in this data object. And if you look deeper, now we know how to write a loop and how to look at the data. You can actually print out all of the latitude and longitude, all of the coordinates of all of the stops from Las Vegas to Los Angeles, right? And once you have this data and you know Python, you know how to use databases, maybe you can import this into your own database, or you can apply other operations on all these numbers, right? So that's kind of a way, and I actually verify this. The starting point, if you go back to Google Map, you enter these coordinates, it actually is somewhere in downtown Las Vegas. And the last stop is actually very close to Los Angeles City Hall in downtown. So you can retrieve all of this data in Python, and then you can apply your additional operations. Another example is that suppose you see a table, right, from, say, Wikipedia. So I have this table. And then you may think, oh, maybe I want to use the data in this table. But the data this is a HTML it's good for display on a web browser, but it's not directly useful for me. But in Python, you can quickly pull this data into a Python data structure. And there are multiple ways to do it. One way is this is one of the mainstream data analysis module in Python called pandas. So in Panda, I can read HTML from this address. This is the table, the one we just saw, and with some additional arguments. And there are multiple tables in this web page, and we are looking for the 6th table in a page. And if you pull this index, because it will return a list, and this is the 6th element in the list. We call it T. If you print out the first 20 elements in T, that's exactly the table we were looking at. And now the difference is that now you have everything in Python data structure, and you know how to deal with the list, you know how to deal with the data, and you can apply additional operations. So you see a pattern here. Everything is kind of a Python-centric in a sense. And in Python, you will use the corresponding modules or toolboxes to be able to interact with other data sources. The data sources can come from some internet sites like JSON or HTML, can come from some other databases. Maybe you created this from another project, and the databases can be local or remote. And Python can also interact with the operating system, right? For example, the machine can be running Linux, can be running Mac, Windows, and you may have to deal with some kind of local time or different time zones. And some of the data is not very clean, right? Data may contain noise or some kind of, for example, some broken records. And you have to clean up before you use them. And the data may be stored in different formats. And also at the end, once you do the processing, you may have to present your data, or you have to show it in a professional or effective way. And so data visualization, presentation is also very important. And also for other purposes, you may have to access, maybe you cannot write everything by yourself, and maybe that thing is not available in Python package, maybe it's written in C or C++ in a different libraries. And Python actually has a very good, easy way to integrate Python with some of these other codes. So you can integrate your thing and kind of take a free ride on these other existing codes. And so we kind of briefly mentioned some of the Python language features and data containers, and how do you handle errors, exceptions. and how do you kind of pull data, and you kind of see a pattern here. We are kind of, Python is the center, and pull stuff from other sources into Python. Once in Python, you perform additional operations, and then you output. Output can be to a file, can be to some kind of graphics or visualization. And we have not covered a lot of things. It's 1 hour presentation. Obviously, there are a lot of details we have to kind of dive into to understand the language better. And this is what we do in the class starting next week. And there will be more advanced manipulations and you can do. Also, Python is very powerful. And I can say this because I do use these features in my actual work. So I actually depend on Python to do my work. So Python has to work. And there are some kind of software engineering aspects, but they are important for writing any program. So we will also kind of talk about those. And Python can be can interact with the operating system, and you can do data processing, numerical computing, and other things. And with that, that will conclude my presentation, and I can take some questions, although I think we are a little bit out of time, but I will be happy to take questions.
I had a question.
Yes, please.
So I can see how you can use Python to interact with all of those applications, but where do you actually, you can save the Python scripts to a file on your drive, but how do you actually call those within another application? Is there a way to do that?
Yes, you call Python. Standard way is there's the command is actually Python. So basically Python and the script you run. So that will execute your script.
So can I, for example, like execute a Python script from within Excel itself? Like if I were to run a VBA macro that could call Python code so that my user doesn't have to go onto my desktop and find my Python code and run it. Does that make sense?
Yes, it's for Excel, I'm not sure, but there are other programs you can you can launch Python from within that application. For example, but for Excel, I'm not sure.
Are there other examples?
It kind of depends on the system you have. Can the system launch another command? If the system supports that kind of feature, and that command will be your Python script. Okay.
Are there examples of applications that you know can?
For example, there's a program called, for example, R. R is another programming language. And then within R, you can execute a Python script, for example. Or you can do it vice versa. In Python, you can execute R. And for the Excel example, I'm not sure if you can, I don't know if you can launch Python from within Excel, but you can do it another way. In your Python script, you can actually read in Excel, and you can make changes to the Excel data and write it back, if that works for you.
And that would be launched through Excel?
No, that will be launched through Python. So you will run your Python program, but the Python program will make changes to your Excel file.
Right. I guess that's what I'm getting at. Is there a way to launch Python without going into the Python application and launching Python that way from a user endpoint?
It kind of depends on that application. For Excel, I'm not sure. Okay, I can.
Okay.
I can find out and let you know.
Okay, thank you.
Right.
Any other questions? Right, and so I know that Shao-Ching said that we're running low over time, and appreciate everyone stay here for this webinar. And Python has become very popular, and especially in the area of data science and data engineering, and that when it comes to manipulating data and data visualizations and data computing, and that Python is one of the very common language nowadays, and that's why we are looking at building and offering a new certificate, basically based on Python, called Python and Data Engineer. So, but for now, I'm going to turn over to Damar, and he's going to basically give you basically just a few seconds and the feel and look of where to find the information, the enrollment, and some of the relevant courses. Then we will conclude this webinar.
Yes. First, I'd like to thank Shao-Ching for stopping by to do this webinar for us. Thank you. Also, I'd like to thank Bruce for orchestrating the webinar meetings. Now, I'd like to dive into related courses for our data science certificate. As you can see, there are 7 courses for our data science certificate. To receive the gold certificate in data science, these courses are listed on the screen up ahead here. Please keep in mind that we're still working on the data science certificate and getting approved. Our goal is to have the data science approved sometime within the fall. Now I'd like to move on to our certificates. Again, you'll notice data science is not currently listed. If you'd like to learn more about a cert certificate, simply click on it, and it'll take you to a page with more detailed information. So in this case, I will click on database management, and it'll take me to a more detailed page regarding database management certificate. Benefits of certificate. Some of you may be asking, what are the benefits of receiving a certificate? Receiving a UCLA Gold Seal certificate can help you set a higher standard in your desired field, opening up doors, interviews, connections, and internships. Having a Gold Seal certificate is a declaration of skill and competence that is recognized by companies and organizations all over. Let's start with the Bruin card. You can use your Bruin card for discounted bus passes, and you can use it as a fee-free debit card. You will have Career Spot and Bruin View. You have access to the UCLA Career Center online, job board, where employers across industries post jobs and interview and internship opportunities at career levels of all over. Also, we're offering career coaching. If you know the career you want to pursue, but don't know how to get there, our online career coaching can help. And one other thing, you'll become a part of UCLA Alumni Network. Once you receive your certificate, you'll automatically be inducted into the UCLA Alumni Association as a member without any additional cost. I'd like to briefly show you how to enroll in a course. First, visit our website at uclaextension.edu and search for something you're looking for. In this case, I'm looking for Python programming. You type in Python as listed on the screen and search by hitting the little search bar or enter. You'll then come across the page that looks more like this. You'll want to locate the course that you want to select. In this case, I've located Python programming here, so this is what I will select. It will then bring you to the course page. To enroll in this course, you'll want to choose a section under Review Sections as listed here. A drop-down will appear listing more information about this class. For example, I know that this class meets on Wednesdays from 6:30 to 9:30, and it begins April 5th and ends June 14th. Also, it lists the course fee, schedule, and location. Simply select on the Add to Cart, and then after you select on Add to Cart, you just follow the instructions from there, and you'll be enrolled in the course. If you'd like to enroll in a certificate, basically you go through the same process. Visit ucla.edu, hover over the browse, click on Computer Science and Engineering, and it'll take you to this page here. And you want to locate Computer Science and Information Systems at the bottom. Click on that, and locate database management or whatever certificate you're interested in. In this case, I'm going to choose database management. And from here, it's going to take you to our database management certificate. Just simply click on the apply now and follow the information from there. For more information regarding our certificates and courses, you can contact my colleague, Denise, at crawford@uclaextension.edu. Her number is 310-825-0213. Or you can contact me at ddouglas@uclaextension.edu. My number is 310-825-7609. Is there anything that you'd like to add, Bruce?
Nope. Thank you very much. And again, thanks everyone for staying here with us on this webinar. And so we will have more of this type of webinars to come, and just watch this space. Thank you very much.